Good day.
My name is Brenda Williams.
My name is Tana Anthony.
My name is Kevin Franklin.
And my name is Tushami Greer.
And we are Group 2.
In this video log, we will be comparing stony coral tissue loss disease and coral bleaching. We will now have Logan Williams explain more on this topic.
My name is Logan Williams. I'm the Education and Research Coordinator for Coral World Ocean Park. And today we've been talking about bleaching and the stony coral tissue loss disease. So corals are animals just like people, but they have this really incredible mutualistic symbiotic relationship with this single-celled algae called zooxanthellae. That zooxanthellae gives the coral pretty much all of its food, up to 90+% of its food from its zooxanthellae, which is great. However, during the summertime, the water temperature increases a little too much for a long period of time, and that coral has to kick out its zooxanthellae. So that is what we call bleaching, okay? And the reason why it's called bleaching is because the zooxanthellae actually gives the coral its color. So without its zooxanthellae, it has transparent tissue, which looks white, hence the name bleaching. However, just because the coral is bleached does not mean it is dead. It is still alive, especially if you are snorkeling or diving on a reef and you get to look at the coral, the polyp structure, you can see that the animal is still there, that the living tissue is still there. And the coral can regain its zooxanthellae, and it can recover from bleaching. However, if it isn't able to do that, after about a month or two, the coral's chances of recovering are very slim, and there's a very good chance that it's going to succumb to at least partial mortality. But if the coral does recover, that's really great news for the coral. However, it has been starving for quite a period of time, and so it is highly susceptible to opportunistic infectious diseases and other infectious diseases, such as white plague. Now, the stony coral tissue loss disease, this is a very interesting dynamic disease. It's a lethal, rapid tissue loss disease, so that means that it actually it's losing its tissue. It's actually dying. So stony coral tissue loss disease, it spreads rapidly from reef to reef, from coral to coral. We know that it does spread through the water column, and so a coral that is down current from another coral could get infected with SCTLD based off of those currents. Stony coral tissue loss disease, like I said, is highly lethal, so it has a 60 to 100% prevalence rate in communities, which is extremely high. Not only that, but it is known to cause mortality in a very short period of time. So in days to weeks to months, the coral colony that is infected with stony coral tissue loss disease can completely succumb to that infection. And once that coral is gone, there is no chance for it to regrow itself back. It is completely dead. So, based off of this disease, it also affects about half of our stony corals here in the Virgin Islands. So it affects a lot of our really important reef building species and also some endangered species as well. So it's a devastating tissue loss disease. It doesn't have a season, which is different from other coral diseases. So it pretty much runs all year long, which is very unfortunate as well. So not all corals are highly susceptible to the stony coral tissue loss disease, and it does vary by different species. Our most susceptible corals are our brain corals and our pillar corals, our maze corals, and our flower corals. And then some more really important reef building corals, such as star corals and starlet corals, usually get infected about a month after those species are infected and succumb to that disease. Now, what are we doing to stop this disease, or at least, mitigate and manage its impact? Well, a group of nonprofit organizations, government organizations, and the University of the Virgin Islands have gone together to create this group called the Coral Disease Advisory Committee. We call it the Coral Disease Advisory Committee because we also have representatives from Puerto Rico who are helping us manage this devastating coral disease. So I'm a part of the VI Coral Disease Advisory Committee, or the Coral Disease Advisory Committee. And what we do is we meet once a week and we discuss different methods and ways to track this disease, figure out how it's affecting our coral reefs, and then different interventions that we can perform to prevent it from spreading and affecting so many corals. And so I'm actually a part of the core strike team, St. Thomas strike team, and out here is actually one of our monitoring stations. So what we'll do is we'll go out on the reef and we will identify corals that have stony coral tissue loss disease. We will photograph them, tag them, and then treat them with this topical paste. It's kind of like a Neosporin, and it has a 1:8 ratio of amoxicillin, which is an antibiotic, And then this substance called Base to B, which was created by Core RX and Ocean Alchemist up in Florida. A lot of work going on with this disease. If you guys want to learn more, please go to the BiCool Disease advice, BiCoolDisease.org, and check out all of the different work that has been going on down here in the Virgin Islands for the past 2 years.
When it comes to environmental impact on VI corals, we believe that if water temperatures are below 83 degrees Fahrenheit, the stony coral tissue loss disease will appear more frequently than the bleaching.
Good day, I'm Candace Wade Franklin, and I'll be going over the materials and methods. For this lab, it was a bit different because we didn't necessarily do an experiment. However, we went on a field trip to collect data. The collecting of data consists of 2 students going scuba diving with Logan and Howard Forbes. Now I'll be going over the materials they needed to scuba dive. The materials they'll need are a plastic clipboard, waterproof paper, a mechanical pencil, a mask and snorkel. You'll need a mask to see clearly underwater. Your eyes must be in air to focus properly, but your mask creates an airspace that you have to equalize. Snorkels are standard equipment because at the surface, they conserve your air supply when you need to breathe with your face in the water. Swimming fin. Swimming fins provide a large surface area for your powerful leg muscles to push against so you move efficiently through the water. Diving weights, a wetsuit, BCD or a buoyancy control device. The BCD consists of an inflatable bladder. This is a very durable bag that you inflate or deflate to change your buoyancy, a cylinder band and harness/jacket. The bladder integrates with the adjustable harness that holds the cylinder on your back. An LPI, low pressure inflator mechanism. This usually sits at the end of a large diameter hose. The LPI inflates the bladder with air from your cylinder via the regulator when you press a button. An overpressure quick exhaust valve to prevent rupturing the bladder due to overfilling. BCDs have 1 or more overpressure valves that automatically vent if the BCD is too full. And a weight system. Many BCDs have special weight pockets that you can release and drop in an emergency. The more weight you need, like when wearing a buoyant dry suit, the more useful these are. A regulator. Your scuba regulator regulates the airflow from your cylinder, hence the name. This allows you to breathe underwater. A cylinder or air tank. This tank is an aluminum or steel alloy container made specifically for storing high pressure air. And an underwater camera. A plastic clipboard, waterproof paper, a mechanical pencil. My scuba diving experience for collecting the data was very fun. It was interesting to see up close how the disease looked and how it is affecting our corals. Surprisingly, there was less stony coral tissue loss disease in the water. Even though we saw less of the disease and bleaching, however, it is concerning because the lesions do spread across the corals very quickly. This disease can kill a coral within a week to a month.
Welcome to the data analysis. In this data table, it shows the data that was collected from Cookie Point site. It includes the types of coral, the water temperature at the time, and the traumas that affected them. Based on the data, we were able to create a histogram that compares coral affected by stony coral tissue loss disease and coral affected by bleaching. In this histogram, you can see that corals affected by stony coral tissue loss disease appeared more than those affected by bleaching. The error bars that are included on this histogram were determined by the standard deviation of the dataset. Standard deviation is the measure of dispersion of a dataset based on its mean or its average. It measures the absolute variability of a distribution. It's normally used to summarize continuous data. On this last graph, each type of coral was displayed to show the traumas they were affected by and how many were healthy out of the total number of corals from the data collected.
The purpose of our lab was to see that if temperatures are below 83 degrees Fahrenheit, then SCTLD will appear more compared to bleaching. Based on the evidence given, bleaching occurs when the temperature goes 2 degrees Fahrenheit above the average temperature, 82 degrees Fahrenheit. And because the average temperature at Coral World was below the average temperature, we were correct and we did not see many cases of bleaching. We got our information from the resources forwarded by Logan. Karen Neely, NSU, SCTLD appearance, VI, CDAC, Coral Health Report PowerPoint, PowerPoint from Andre Bruckner, and AGRRA, detailed survey tutorial.
Here are some benefits of creating lab videos. Doing lab videos help me understand the experiments better. They're fun to create and give me a sense of creativity when editing, and they are also useful to other students who are doing the same experiments.
Creating lab videos is beneficial because it not only helped me to understand more on the lab we were exactly doing, but it also helped me to improve my editing skills and creating videos, and it also helped me to do more research on the topic and get a better understanding.
Lab videos allow us to compare each other's results and experiments, as well as improve and implement on skills that we learned from each other. Lab reports help me to understand more about the content that we're doing the experiment on.
Lab videos help us interact with our information by having a hands-on experience in the project, so we get to learn more and we understand it more because we have to pay attention and we have to put in work. Also, they help us with lab reports by doing the introduction, conclusion, and the methods, so we become better at doing them over time. They also help us with managing our time, having to fit into a 10 to 12 minute video, making sure it's not too short or too long, so we get our information in clear and it's easy for people to watch and understand. And they help us with organizing our information too, so we can make sure that you guys, the watchers, are understanding.